So a lot of these were given in slope-intercept form, and you just had to graph those two and then find if they intersect or not. If it was not given to you in slope-intercept form, if it was given to you in standard form, you would have to solve that first and then keep going. So for this one, these are both in slope-intercept form, so I just have to graph. We're going to start at the y-intercept, so 6, plot a point there. And then the slope for this one is positive 1 over 2, so I can go up 1 to the right 2, and it should graph that line for me. And then I can do the other one. Negative 8 is my y-intercept, so I'll plot a point there. And then my slope is negative 5/4. So if I go up 5 and to the left 4 and plot that point, it should graph my other line. Then I can see where do those two lines cross, which would be at negative 8, 2, and I would write that solution over here because I can't do that on there. Remember, if you have two lines that don't ever cross, they're parallel, that's no solution. And if you have two lines that overlap each other, those are infinitely many solutions. Questions on that? Victoria, did that make more sense? All right, let's look at the chart right. Which of those did we want to see, do, go over, have questions about? Any others you can show me in your hands? There's an interesting mix today. So I saw a few for 3, a few for 2, a few for 5, more than 4. So we'll do those 2, 3, 5. All right, for number 2, write an equation that is parallel to the following. So we're given some equation. If it's parallel, that means the slope is the same. You don't need to write this part, I'm just reminding you. So that means the slope of this is what? The number in front of x. Negative 1, yes. So because it's the same slope, I'm going to use that same slope, negative 1, or you can just put it as negative x, and then we just need a different y-intercept. Someone give me a different number. Sure. Negative 5 would work. 0, a million is not 5. Okay, questions on that? All right, for number 3, we're looking for the equation of this graph. So we're going to write the y equals mx plus b of this. So I see that this crosses the y-axis at 1. My slope of this line, I'm going to find another point that crosses the grid lines exactly. So 2 looks like it, but it's a little above, so not there. 3 is a little below, but at 5, negative 1, it looks like that crosses. So this slope would go down 2 to the right 5. And just to make sure, I'm going to go back the other way, go up 2 and to the right, to the left 5. Sorry. So if I put those two together, y equals negative 2/5 x plus 1 would be my equation. Okay. With these types of problems, you can always put what you think it is into Desmos and see if do your line and the one that's graphed match. Questions on that one? Yes. So the negative needs to either go out front of the whole sign or up top. It just can't go in the denominator. But it reads the same either way. For number 5, Number 5, we have to find the x-intercept, which means our y value has to be 0. We're going to put 0 in for y. And then we're going to solve for x. How would we do that? How would I start to get this x by itself? Not divide first. Multiply by 1. So you could do that to get rid of the fraction, multiply everything by 3. So sure, let's do that. So now we don't have the fraction, but we still have to get x by itself. What would be our first step? Say again. Yes. We could have also just added 6 here. Right? And then to get x by itself, last step, then divide. So that x-intercept would be 9, 0, since our y value was 0. Questions on that? Okay. I want you to write this down on your notes, and then we will continue when we get back from lunch. By graphing last time. Today we're going to talk about solving systems using substitution. So I'm just going to read through this and then we're going to put this into practice. So when we solve by substituting, we're taking one equation and we're substituting, replacing it, putting it into another. So we're going to solve one of the equations for x or y unless one is already solved. Then we're going to take that equation, substitute that into the other, and solve for the remaining variable. And then once we get our final answer, x equals something or y equals something, we'll take that number and substitute it or replace it back into one of the equations to get that final answer. Anyone still need this part? We're going to start at example 1. I'm going to come back to this. So in an example like number 1, if we were to solve for x or y, well in this one, that's already done for us. Both of them are already solved for y. So when you have two equations that are solved for the same variable, you're going to set them equal to each other. So the substituting would look like this. I would either take this equation and put it in place of this y, or take this equation and put it in place of this y. How that would look would be putting 4x minus 1 on one side and 2x minus 5 on the other. Doesn't matter which side is which, but you substituted that into the other. Now this is something we solved before, so we can go ahead and solve this. What do we want to move first? The 2x. Okay, so let's do that by subtracting. And then we can also get rid of the 1 by adding it to the other side. So that the 1's cancel, the 2's cancel, and we have 2x equals -4. And then divide both sides by 2. So that x equals -2. Okay, so that's part of the problem. We have found x. Now we have to go back and find y. So when we find y, you're going to take this -2 and you're going to put it in place of the x in the original equation in either or. You don't need to do both. You can do both as a way to check yourself, but you don't need to. So let's say I put this in the first one. Y equals 4 times -2 minus 1. And then I simplify this and I see what y is. Y should be -9. Once you have that x value and that y value, you're going to put those together in an order pair. -2, -9. Always x, y. Brianna, are you writing this down? Yes, Eric. From the x.
Okay, so is our x always going to be
First. So in this example also, as we start to solve, we got an x. That's going to tell us this is going to be one solution. It's going to, these two lines would cross at some point. I could also look here. They're not parallel, so it's not no solution, and they're not the same, so it's not infinitely many. So that would mean by default they have to cross somewhere, and we are going to figure out where that is. Any other questions on that one before we go into the others? Another question. So in the next one, we have an equation that's solved for y. The second one is not, but that's okay because we just need one. So this one's going to be a little different. We're still substituting, but it won't look the same. We're going to take that expression that y has, and we're going to put it in place of y for the other one. So we're going to rewrite that second equation. 2x stays the same, plus 3, but then in parentheses, I'm going to put 6x equals -20. I've taken that y equals equation and substituted it into the other one. Now we can solve this. Multiply 3 and 6. What would be my next step? Combine like terms. 2x and 18x to get us 20x. And then divide 20 on both sides. So that x equals -1. Any questions so far before we go ahead and find y? Okay. And then we're going to take that x. So I should have done this in the last one. Drew an arrow. But I'm going to take that -1 and I'm going to put it in place of x. Now you have options. You could put it into either, but this one you would then have to solve for y. This one's already in y equals, so that one would make your life easier. So I'm going to put that -1 in for x and solve. So this would be one solution. How would I write that? Think about how we wrote our one solution before.
-1, -6.
Yes, -1, -6 in parentheses. Any questions about that? in the next one, same process. I have a y equals, so I'm going to take this expression and I'm going to replace the y in the other equation with it. So I'm going to rewrite that second one to look like 3x plus 8 parentheses x plus 9 equals negative 5. So each time we're just taking that equation, substituting it in. Then I could solve this like a normal problem. Distribute the 8. And how would I start solving this one? Yes. Add the 3x and the 8x to get 11x. And then so we have 11x equals negative 77. And then divide. What is x? Okay, so now let's find y. Take that number, put it into x. So again, you can use either or, but using the one that's already y equals will help you make your life a little easier. So that would be y equals negative 7 plus 9. What would that y value be? So our ordered pair would be negative 7, 2. Any questions about this so far? We're just going to do a few more examples, and then you guys are going to practice, / if you need to finish tests, work on grade papers, you can do that. Okay. What's different about number 4? Yes, but what does it have? It has an x equals. So it does not matter if you have x or y, as long as you have one of them, you can do this process. So this one's just going to be the opposite. Because now I have an x equals, so I'm going to take that and put it in place of x instead of y. So when I rewrite that, it'll be 2 parentheses 4y plus 7 minus 6y equals 12. The main thing with this is substituting into the right thing. You know something's off if when you substitute, you still have x and y. You may have substituted incorrectly. If you only have one variable, like all x's or all y's, then you're fine. Okay, so to solve this, we would distribute first. Combine like terms just like we did in number 3, 8y minus 6y. Get rid of 14. And divide everything by 2. So in this one we solve for y. Now we're going to go back and solve for x. Find our x value by taking that number and putting it back into our x equals where y is. So that would look like x equals 4 times negative 1 plus 7. And if we simplify that, our x value should be 3. How would I write that as an ordered pair? The x first. So 3 and then -1. So just be careful with things like this, because we solve for y first, that doesn't mean y goes first. It's still x first. Questions on that one? Trying to think which one should be the best. And then we're going to do 5, and then let's go to 3, 7. Okay. With the questions on the back, what do we notice about those? Yes. What's different about those than the ones we were just doing? Right. These do not have an x equals or a y equals, which means we have to solve these ones. You can solve for whatever you want. So I'm just going to say that. You will get fractions and decimals depending on what you solve for. However, if you look for whatever's by itself, or maybe almost by itself, maybe it has a negative. I was looking for one like an 11. If it's just an x, just a y, or a negative x or a negative y, that would be the easiest thing to start with, because that's going to make your lives easy without fractions. Okay, so let's say I'm solving this equation for y. How would I get y by itself? Yeah. So that would be y equals negative 2x minus 2. Now I have a y equals by itself. Now everything else is going to be the same. So we'll do that one. Now I can take this, put it in for y, and the other one, rewrite that one as 5x plus 3 times negative 2x minus 2 equals negative 8. Distribute and solve. So here when we combine our terms, we get negative x minus 6 equals negative 8. Get rid of the 6 by adding. What's that last step? Okay, so these are already multiplying, so we would want to do the opposite. Divide. Yes. Okay. And then take that x and put it back into y. So again, you have choices. You can put it into either of the originals, but since we have that y equals, I'm going to put that in there. I'm going to draw an arrow. So that I'm going to rewrite this equation, y equals negative 2, put this x in 3. Oh, thank you. Negative, positive 2. Okay, not 3, 2. 4 minus 2 or negative 6. And that would be 2 negative 6. I mentioned that your main goal is make sure you're substituting it incorrectly, but also make sure you're substituting into the other equation, not into the same one, because then everything's just going to cancel. There are times where that does happen, but if you put it back into the same thing, then it's going to cancel by accident. Okay, we're going to do one where things might cancel, where you might get a no solution or infinitely many, and you'll see that really quickly if that happens. So let's do number 7. What in number 7 should we solve for? What would be the easiest thing to solve for?
Oh wait, I was reading 6.
For number 7. The x. In which equation? The top one. So if I solve for the first x in the first equation, that will make our lives the easiest. Because how would I get rid of 5y? The x equals negative 5y plus 4. And then I can take that equation, substitute it into the other one, where x is. So that would look like 3 times negative 5y plus 4 plus 15y equals negative 1. So let's go ahead and distribute that. When we go to start solving this, what's going to happen? For what? So when I combine these two, that would give me 0. And I don't need to put 0y. I can put 0 if I want, plus 12. But that would just be 12. Negative 1, sorry. Does 12 equal negative 1?
No.
No. So what type of solution would this be?
No solution.
No solution. So you would find out early on if this is going to be a no solution or infinitely many, because your variables are going to cancel, and you'll be left with either 2 numbers that don't equal or 2 numbers that do. The same number that is. Okay. Questions about that? I'm going to let you guys practice. You can do a few things. You can keep practicing in the notes. There is a Delta Math on this that's due on Thursday. If you need to finish the tests, you can do that. Or if you want to work on retake work, you can do that. Reminder, tomorrow is the last day to do retake work for marking period 1. Thursday is the last day to retake, if your retake work is done, / turn in missing work. If you're missing work, you can also work on missing work from Delta Math.